Now we move on to the shift and bitwise operators. First, it's about the shift operators. The shift operators is do shifting operation. Means we have a number and then we shift it from the left to right or from right to left. The different directions. We have two kinds of shifting method. The first one is arithmetic shifting. The second one is logical shifting. What's the difference? Well, first we look at this arithmetic shifting. Arithmetic shifting, we have this sign as this is shift from left to right, and this is reverse the shifting from the right to left. Okay, and the first operand is a number we want to do shifting, and the second operand is a distance. In other words, it's how far we do shifting. Yeah, there's two directions to arithmetic shifting, from the left to right and from the right to the left. Okay, this is the arithmetic shifting. And if we want to do this logic shifting, we use a different sign as this from the left to right. We do the logical shifting operation. Okay, they are different. I'll give you example to show the difference between them. Okay, now suppose we have a number 128. This is a number want to do shifting operation, and the distance is 1. Okay, let's do this arithmetic shifting. And before we do it, we should know this number inside the computer, what it looks like, because all these numbers stored in the computers as 2's complement code. So we should know what this complement code, the 2's complement code looks like. And as we know, this is int, the literal number for int, for integer type. So 128 is the 32 bit inside computer, and if we put it in the computer, it looks like, if we write in the hexadecimal format, it looks like this is the 128 in the hexadecimal format. And if we want to truly understand how the shifting works, you should convert it to the binary code that make this process clearly. Okay, so we write it, this hexadecimal we write as the binary code, so as the 8 we write as 1 0 0 0 with 3 zeros, and this is 8, and this is 4 0. Okay, this is 8, this is 0, this is binary code, and before the 8 all zeros. Okay, a lot of zeros in from this 1. Okay, this is the binary code. We have 32 bits. And we want to do this shifting work means we shift the number from this left side to right side. Okay, the distance is 1. So only shift 1 bit. Shift 1 bit means here we have this. This is 1. And we shift 1 bit. So this number 1 and this position and to the right side, the next position. So if we shift it, so the number becomes this. Well, it become this. And well, with 1 0 0 0, now it's 0 1 0 0. Okay, shift from left to right at one distance. And it's very important that because we set it 2 bit, all the numbers shifting from the left to right, and then the highest bit. What is the highest bit? So in arithmetic shifting, the highest bit is come from itself. So if this number is 0, it's come from itself, so it's 0. So we get the result as this. That is 0 1 4 0 1 0 0 0 0 0, the 4 0, and the 0 1 0 0, right? There's hexadecimal as 4, as 2 0 as 0, and all this one, because this highest bit itself is 0. So the 0 comes into the very beginning of this byte. So this 0, so get the result as 0 0 0 0 0 4 0. So it is a final result if we do the shifting operation. If we write as this decimal format, we get the result as 64. Okay, this is the result. And if we do another shifting, for example, we have this number as 256, and do the right shifting, the arithmetic shifting, and the distance is 4. That means we shifting 4 bits. Shifting 4 bits means 4 bits is just as 1 hexadecimal. So there is 1 and shift 4 bits, so becomes 0 1 0. And because all the bits shifting to the right side, we have 4 bits shifting from the left to the right side. So at the beginning, which number will comes into it? It itself is still the 0 because it's the positive. In the complement, it's 0. It's the positive number. So the 0 comes in the highest bit. So get the result as this 0 1 0. You write as decimal format is 16. Yeah. Okay, that's the result. This is we do arithmetic shifting. But if we use this arithmetic shifting to operate on the negative number, here's a negative number with a minus 256. It's a negative number, and negative number, if you write its 2's complement code, that is inside the computer, so minus 256 will looks like this number. Yeah, oh, the F. F stands for 1 1 1 1. Okay, so we have this number, and what we will, the distance is 4. So we shift from left to right, we shift to 4 bits. And because it's arithmetic shifting, so what is come to the very beginning of the byte? Yeah, itself, because here the self is 1. So the 1 will come to the very beginning of the bytes, bring 4 1 into it. So just 1 F as a hexadecimal number. So we get the number as F, 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 4F, and F, 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 3F, and 0 in hexadecimal. If you write this hexadecimal, we convert to its decimal number, it's minus 16. So it's arithmetic shifting. But if we want to do this logic shifting with different symbol, with different operator, we do the logic shifting. The logic shifting, this is important. That is totally different from this arithmetic shifting. That is, if you shifting from the left to right, which number comes into the very beginning of the bytes? Not itself. Only 0 comes to the very beginning of these bytes. So only 0 comes to the very beginning of the bytes, not the bits itself. So if we do the same operation to the minus 256, but this time we do this logical shifting. So the logic shifting, as we know, the 0 comes to the very beginning of the bytes. So 40 comes into the beginning. So 40 comes into the beginning, and then we get this result at 040 in binary code, and stands for, if you use a hexadecimal, it is 0. So the result is 0 and 3F and 3F0. It's this result if we convert it back to the decimal number. So decimal number is a very large numbers here. Okay, this is the logical shifting. This is different from this arithmetic shifting. And if we shift a number, the distance, it's equal its size. For example, 128 is a natural integer number, so its 32 bits, its size is 32 bits. But if its distance is the same as its size, at its 32 bit, it is 32, and if we shift it at 32 bit, and the result is the number is keep the same, it's not be changed. Okay, this is about the shift operators. And next, we'll see the bitwise operators. The bitwise operators, look at these symbols. It's the same as we have to use before to do the logical AND OR operation. It's the same, but here it's not a conditional operators. It's a bitwise operators. It's different. The difference is the two operands. If we do this bitwise operators, the two operators should be the numbers. For example, the integers or bytes or something else. They must be numbers. So we do the bitwise operators. But if the operator is the same operator, but we perform the operation is conditional operator. These two operands must be Boolean value. So this is different. Okay. Now this ampersand is AND, and its bar is OR, and caret is equals of OR, and the tilde as complement. Okay. So we'll give an example. Let's see, we have three integers. The value is 1 and x equal 1, y equal 2, and z equals 3, and then we do this statement. This statement, we use this ampersand. The ampersand, here the ampersand means to this conditional operation. Okay, so conditional operation means the first operand and the second operand, they are all Boolean. So we know that the x less than y and y less than z, that gives the result as a Boolean. The x less than y gives our result as true because y less than 2 and y less than z is the same. We get the Boolean value as a true. So the operand, the first operand is true, the second is same is true. So we make this as AND operation. The result is still a Boolean. It's true. Okay. This is operand. Now he worked as the operation operators. Now worked as conditional operators. Okay. And next, we have two numbers. The two numbers with byte type. They're primitive byte. So it's x, we write it as hexadecimal as 55, and y the hexadecimal as 50. And now we do this operation. Use bitwise operator. Here's a ampersand. It's a bitwise operator. So the x and y, how to do it? We can do it if we write down the binary code for the x and y. So x, the binary code is because it's byte, so we have 8 bits. That 8 bits. 8 bits to write from the left to right as 0, 1, 0, 1, 0, 1, 0, 1 is 8 bits. And there's a y with 8 bits and 0, 1, 0, 1, 0, 0, 0, 0. Alright, okay, good. And now we do this AND operation. Remember, here we do the bitwise. So bit by bit, we do this operation. 1, yes, 1 and 0 gives us result as 0. 0 and 0 gives us 0. 1 and 0 gives 0. 0, 0 gives 0. The 1 and 1, okay, gives 1 to the same 0, 0, 1 and 0. So we got the result. The result is the same as 50 as a hexadecimal. So this is the result. We assign its result, this value to z. So this is a bitwise operators. So this is different. They're different. So you must remember the difference between this bitwise operator and the conditional operator. That point is the operands, the different operands. If you do the conditional operation, the two operands must be the Boolean variables. But if you do this bitwise operators, the operands, two operands, the first and second operands must be the number. So this is different. Okay. And assignment operators is very simple. Assignment operators we use this equal sign. Equal sign, we make this assignment. Yeah, put this value from the right to left. This assignment operator. For example, now we have the int, we have the integer variable as x, and we assign a value 1. Yes, so 1 was assigned to x. Use the assignment operator. Okay. Now we have a special operators. That these operators is combined this arithmetic operators with this assign operators. We get this shortcut assignment operators. Okay. For example, now we put this plus sign and equal sign, the two operators together, we get a shortcut plus sign equal. This means the first operand, the second operand, that's the same as we add the first operand with the second operand, and the result we assign it to, send it back to the first operand. It's the same. It's the same. And now have this this the minus sign with the equal sign, the same as with the we'll subtract the second operand from the first operand, and the result we assign back to the first operand. It's the same. This shortcut assignment operators. Okay. And other operators, we have other operators. For example, it's this a question mark and a colon. This we give the name as shortcut if-else statements. We'll give example in next section about this if and else statements. Okay, and this square brackets, we use these square brackets in the future. We use it described as arrays. Okay, we're talking about this in the next chapter. And then start. The start in the qualifier name, we start to form a qualifier name, and this the parenthesis into the parenthesis is a parameter. Okay, we have the type. This type inside the parenthesis is a type. This type means we make a cast operation. Use this operator. What does cast mean? From one type to another, to a specified type, we use this operator. For example, now we have a number. For example, we define number as a byte, and it's A. Yeah, it's a byte number, and we give its literal value as because byte. Give this 55. Yeah, this is A. Yeah. And then we define an integer as B. And now we do this operation. We use this cast operator. We do this casting as. Okay. Now we put this type inside this parenthesis. It's a type. It's int, means we convert a byte type to an integer type. This is the cast mean. And new, and this operator new will be used to create objects. In the statements, we create an object based on this blueprint. As you know, the prototype of a cast code. We use the cast code. We create an object. Use constructor. Or use this operator. So we'll talk about it in detail. Talking more in the next chapter. And instance of well, it means whether the first operand is the second operand. It is an instance of a second operand. Okay. It's a tool to check this relationship.